Swayam Prabha. Digital India. Educated India.
Welcome to lecture 28 of module 6, where we will continue discussions on mechanical testing of the surfaces, different properties, mechanical properties of the surface, as well as different testings which are applied for testing of the electrochemical properties of surfaces. So, we were discussing about the scratch testing. So, one of the purpose of the scratch testing is measurement of the coating adhesion. So, apart from that, scratch testing is also applied very much for the measurement of the wear resistance property of the component. So, for example, if you do scratch testing, you basically while doing scratching, you just go on just the different parameters which are applied for scratch testing is the applied load. So, you can vary the applied load, you can vary the time of the interaction of the scratching indenter with the surface, and you can also vary the time, temperature, pH of the environment depending on the requirement. So, these are the different variables which you can vary while doing the testing. And if you just think of the output parameter is the loss of materials because of scratching. So, and second output parameter is the coefficient of friction. So, if you just go on measuring the just weight loss of the component as a function of number of scratch cycles and also time, and you will get information about the amount of material which is lost because of the wear or because of scratching. So, and also if you measure the coefficient of friction, you also get information about the coefficient of friction value, how is it changing with the composition of the coating or how is it varying with the application of coating. So, if you just quickly go to the coefficient of friction value, how it is dependent on the parameters of the surface, they are actually the hardness of the coating. So, as you go on increasing the hardness of the coating, you will find that coefficient of friction changes. So, there also we found that if it is soft to hard to soft combinations, then coefficient of friction is usually higher, but if it is soft to hard compositions or soft to hard combinations, you will find that coefficient of friction is lower. Similarly, thickness of the coating. So, thickness also, with changing the thickness of the coating, you will find that coefficient of friction again changes. So, thickness of the coating, if you just think the case for soft to hard combinations, you will find that this particular scratch material loss due to scratch is higher than that of hard to soft combinations. Then surface roughness also influences the that coefficient of friction to a large extent. Higher the surface roughness, higher is the coefficient of friction, and if there is debris formation, depending on the kind of debris that forms, the particular coefficient of friction will also vary actually. So, initially the coefficient of friction might have one particular value, it can change with the change in the scratching or maybe change in the wear because of the formation of wear debris. So, if you just quickly go through the scratch testing failure mode, this is coating hardness as a function of substrate hardness, and if you just see the different zones of scratching, you will find that there is plastic deformation zone, there is throw thickness coating, that coating cracking zone. As the coating hardness increases, if it is very hard, it is harder than that of much harder than that of substrate, you will find that there is throw thickness coating cracking. Then it can be there if substrate hardness is relatively harder, there may be buckling or spoliation and there may be chipping action. On the other hand, if it is low hardness and substrate hardness is also moderate, there may be plastic deformation. Now, if you just quickly go through the how the coating that substrate combinations changes that different or what are the different parameters that basically changes the wear due to scratching. You will find that materials geometry plays a very important role, and what are the, for example, microgeometry, topography, whether loose particles are there, whether any fluid or environments are there. There are properties like chemical composition, microstructure, shear strength, elasticity, viscosity. Then what energy input is there, like velocity, temperature, load and tangential force. And then obviously the mechanical changes are also there in the surface because of the interaction. Tribological changes are also there. There may be some material transfer while scratching, and output parameters are how the geometry is changing, how the properties are changing actually as compared to that of input parameter, whether the energy, how the energy input is in form of friction, wear, velocity, temperature and dynamics. So, it is basically a very complex process. So, if you would like to understand the mechanism, you have to see how it is changing with time and how accordingly the output parameters are changing as compared to that of input parameters. So, now we will just discuss about the different other wear testing procedures or wear testing standards which are applied for testing of wear. So, one important type of testing which is often applied for the measurement of wear resistance property of the surface is spin on disc testing. So, in this spin on disc testing, your surface is used as a kind of pin, and that pin is having some specific dimension, and your abrasives particularly or maybe your counter body is taken as a disc, and with this particular technique the standard is ASTM G99. With this testing you can measure adhesive wear resistance property as well as the abrasive wear resistance property, but load is fixed and it is compressive. So, fatigue testing cannot be, fatigue wear testing cannot be performed using this particular equipment. So, what happens is that the relative motion is provided by the motion of this particular mating surface, which is nothing but the disc. So, if you just see the variables, you can have the arrangement of the heating from the back side of that particular disc or maybe pin as well. So, the parameters which you can change in this particular coating testing, this particular testing is the, you can change the compositions of this particular disc may be of metallic, may be of ceramics. So, your parameters are composition of the disc or maybe composition of the mating surface, the rotation, that is you can say that what is RPM rotation, it is nothing but you just do in the form of measure in the form of RPM. So, you can vary the RPM, you can vary the applied load, you can vary the time, you can also vary the environmental condition, that is humidity in the environment, by having by putting a closed chamber. So, different these are usually open testing process, but you can also have the closed testing provision where you have the separate environment where you control the humidity, temperature, and then you just go on recording the material loss or loss of the material from the pin surface as a function of time, RPM, then temperature, humidity, these all things you basically measure. So, second type of, so this testing is very useful for the measurement of bulk wear resistance property, or maybe you can say that where your component is very big, you are interested to measure the wear resistance of the whole material. So, what you do is that obviously for functionally graded component where composition changes with position, for that case this all wear testing you have to be a little careful, then you have to location wise you do wear testing. But if your composition is more or less homogeneous and then you are interested to know the bulk wear resistance value of this material of the component, then you take it as a pin, so that pin is uniformly subjected to wear. So, you can understand this if you take the other way. For example, if your component would be disc and your your indenter would be pin or other surface would be pin, in that other case you would get information about only the contact surface, which is not really full surface. So, the concept of this particular wear testing is that you can do wear testing of the whole surface as a whole by doing this P naught d square testing machine. But this particular things, what you measure the wear loss in terms of that mass loss. You can also see the microstructure, you can also of wound surface, you can also do phase analysis of the wound surface. From there you can understand if there is any adhesive interaction between the meeting surface and the pin. Second type of testing, which is the ASTM G133, which is linearly reciprocating ball on flat disc testing. So, this is a particular testing which is mostly applied for the wear resistance of the coating material. So, here actually you take the ball as the indenter and your disc is coated disc, actually it is coated material. The disc you can say that shape and size may be varied. So, here main parameters are again the sliding motion, the sliding distance, stroke length. You can say it is as it is reciprocating. So, you can say that the rate at which it is moving, and also applied load which you are applying. You can also have the oscillating drive, from which you can have the typical oscillatory motion between the two surfaces. So, you can change along with the sliding motion, you can also introduce typical that fretting motion. So, this particular testing can be applied for the wear resistance of the coated surface very nicely, because here the wear zone is very low. You can confine the wound surface to a very little extent. You can vary the wound surface length from, for example, 1 millimeter to as high as 4-5 millimeter. So, stroke length may vary, stroke length can be precisely controlled to even 10 to 15 micron value. So, this is a very good testing for not really 10 to 15 micron value, but rather it is 1 to 2 millimeter you can say, because contact point usually 0.5 to 6 millimeter. So, you cannot have the that particular stroke length lower than that of contact point diameter, contact point surface area. So, now if you are interested to know the abrasion wear testing in a kind of industrial scale component, where you have that lot of abrasive comes from the different sands or other abrasive species, there this particular testing is used, which is called dry sand rubber wheel abrasion testing unit. This is for low stress abrasive testing measurement or behavior of low stress abrasion test. You can measure with this particular test. So, where you basically have this particular rubber wheel which is moved, which is rotated, and wear testing specimen is kept somewhere, it is fixed, and you go on just flowing sand at a very low rate, and the rubber wheel is actually moved over the sand. So, when the wear occurs, basically there is interaction between sand and that of the material surface, but at a very low load, because rubber wheel you can apply, you can understand that with the help of rubber wheel you cannot really apply very high load. So, very low load is applied and sand is there. So, this situation is similar to that of the sand moving over the surface of any solid at a very much lower load. So, this is a kind of test which is basically applied for low stress abrasion testing unit. So, here a test specimen is forced against rotating rubber wheel and silica sand. It is metered in a flat stream into the rubbing contact. A crescent shaped scar is made in the test specimen, and the test metric is wear volume obtained from mass change measurement. So, mass change can be measured to know the volume of the wear. So, whenever you are interested to measure the high stress abrasion wear resistance property, so the standard is ASTM B611. So, here this is A is the test specimen which you just keep like this, and B is the steel wheel. So, instead of rubber wheel you use basically the steel wheel, and this is the test slurry, C is the test slurry, and D are the veins. So, you can understand that here test slurry. So, this is basically very hard material, slurry contains lot of hard materials, and that is basically moved against the surface with the help of steel wheel. So, here the situation is similar to high stress abrasive wear. If you are interested to measure the liquid impingement erosion testing, so there are other reconfiguration that will this test is very simple. Basically, you can also have this particular testing in your laboratory, where you have that liquid, you have dispersed solid particles in the liquid media, and then liquid media is basically moved at a determined RPM. So, you can have this particular movement with the help of a kind of you can have this you can have with the help of a starter, you can have the movement of the liquid, and that particular starter movement introduces motion in the liquid, and if you keep your component in the liquid media, you will find that at a regular interval there will be removal of the material from the surface that you measure. You can control the temperature, you can control the pressure, and you can also introduce the cavitation condition over there by putting ultrasound from the top surface. So, you can vary the conditions as per your own requirement and have the testing of both the liquid erosion testing, liquid impingement erosion testing, as well as cavitation erosion testing. This is the case where typical cavitation testing is facilities are shown. So, this is a kind of test where it is pressurized water is just moved through the nozzle, and then there is vortex formation, and that is basically moving on the surface of the Rig vortex cavitation is there, where you basically keep the component. You will find that component is subjected to this cavitation erosion at a regular interval of time. You know the surface, you just measure the wear loss of the component, you also measure the surface condition, and you correlate it with the conditions. Here basically the parameters are like pressurized water, water pressure, your other parameter is number of bubbles that is formed, and these all temperature, pressure, these are all variables where which you have to note down while reporting the result. So, ASTM G77 is another kind of wear where adhesive wear testing unit, where sliding wear is used by block or rig wear testing. So, this is typical adhesive wear testing unit. So, where you have the test block having uniform load distribution, load is applied, and this is the meeting surface test rig which is rotated at a specified rate. So, you will find that whenever it rotates there is sliding interaction, and also you will find that there may be adhesive interaction too, because both the materials, if it is metallic in nature, you cannot really avoid the adhesive interaction. So, gradually you will find that there will be transfer of the materials. So, you regularly at a regular interval you measure the surface condition as well as you measure the weight loss of your test block, and you note it down as a kind of wear. So, wear volume or mass loss due to wear is measured as a function of time. Certainly, here if you are interested, you can also have a kind of, you can also measure the typical that friction force, and subsequently you can also have the provision for the measurement of the coefficient of friction value. So, if you are interested to know the wear value in presence of corrosive media, then that is you can say that the test is called tribocorrosion test, where you can do the testing without any electrode, but you can also use the reference electrode and counter electrode. You apply load, keep your component. So, your component is subjected to both wear and corrosion simultaneously, and you can measure the weight loss as well as you can just note down the variation of the E as a variation of current density as a function of the applied you can say that voltage. So, this is typically very interesting kind of testing where from you get information about the contribution of wear and corrosion when the component is subjected to both wear and corrosion media. So, this is very important test, and whenever you see this kind of test, you will find that usually this particular test again is not really so much simulated testing, but you can also have the simulated testing facility where you can have the similar media as is there in actual environment, and you can also wait for a long time and then allow only chemical corrosion to occur, and along with that you can also have the situation of wear which is existing in the actual situation, actual condition, simulated condition. Now coming to the another important property, that is fatigue. So mechanical property, that is fatigue. So we will just quickly go through the fatigue testing. So in fatigue testing what happens is that, as I mentioned you, it is a particular kind of property where component is subjected to dynamic loading, or maybe you can say that fluctuating loading, and you basically you just go on recording the properties in terms of number of cycles for failure of the component, number of cycles for as a function of, you can say that either it is stress range, or it is, or maybe it is average stress, or or maybe average stress, or maybe stress range, or maybe you can say that it is the stress ratio. So these all stress terms are there which is varying, and you can just find out the number of cycles to failure. So this is a kind of testing where low cycle fatigue testing. So where you just keep the component loaded and under the dynamic loading and record the number of cycles for failure initiation, and you find out that stress strain diagram, and from which you can get information about the fatigue behavior of the component. There is another testing by which you can measure the fatigue property, that is called rotating bending testing. Here the component is basically just fixed in a kind of bearing house, and specimen where the specimen can be moved, and you apply the load in such a fashion that the component is subjected to both compressive as well as tensile loading because of the bending of the component. So when the component is bent, for example, the outer surface is subjected to tensile loading, the inner surface is subjected to compressive loading. So if you rotate it further, then you again, if you apply load, you will find that the reverse thing occurs, that is outer surfaces, which was outer surface becomes the inner surface, and which was inner surface becomes the outer surface. So again the same outer surface is subjected to just compressive loading. So by that process you can understand that same surface is subjected to both compressive and tensile loading, and you just find out the number of cycles which cause the initiation of the crack. So that is recorded as a function of that stress range or stress ratio. So that is how you find out the SN curve. You have to, in this particular test, you have to measure a number of cycles where you go on changing the value of load. So and this particular case you can understand that it is basically that it is a test which can take care of fatigue testing of the component having the uniform tensile and uniform compressive load parameter. Here you cannot change the compressive or tensile load parameter in a varied way, because whenever you are applying the load and component is bent, then naturally same load is applied when the component is bent. So there is no change in the load parameters. So there are several other standards which are applied for the measurement of fatigue testing, like ASTM C1360, where constant amplitude axial tension cyclic fatigue testing for continuous fiber reinforced advanced ceramics, and this can be conducted at a very high temperature, because for ceramic material that cyclic fatigue testing, if you talk about, you have to also think of temperature. Then ASTM C1361, which is complex constant amplitude axial tension cyclic fatigue testing. Test can be again performed up to 2500 degrees Celsius. ASTM D3679, this is tension fatigue. D7791, this is uniaxial fatigue properties of plastic. So E466, this is force controller, constant amplitude axial fatigue testing of metallic material. Then 606 is the stress control fatigue testing, strain control fatigue testing, and ASTM E647 is the measurement of fatigue crack growth rate you can do. So different testings are available. So these all ASTM standards are well documented in ASTM data book. So from there the protocol for testing is available for each and every testing. So you can refer that and do the testing for the measurement of the fatigue property or evaluation of the fatigue property of the component. How much time is now? So this is the thing which we can do. So you can understand that in this particular talk we discussed about the different testings which are applied for. So in this particular talk we discussed about different techniques which may be applied for the measurement of the hardness as well as that wear resistance and also fatigue property of the material. But you have to be very much careful in choosing the proper technique for proper purposes. Like if you are interested to know the wear resistance property of the coated component, so in that case certainly you have to understand the for which environment the coating is developed, or maybe what is the environment for which you are interested to measure the wear resistance property of the component. So if the environment is such that applied load is not really very high, but rather you can say that usually it is stress is not really so high, but abrasive action is taking main role for controlling the wear process actually. In that case you have to go for typical this particular low stress wear resistance property measurement like ASTM G65 low stress abrasion resistance measurement technique. The case where you are interested to measure the bulk mechanical properties, bulk wear resistance properties, you have to go for this pin on disc wear testing machine or pin on disc testing. If you are interested to measure the bulk wear resistance property at a high temperature, you have to increase the temperature. If you are interested to measure the typical you can say that coating, where coating thickness is not really so high, but it is hard coating having very low thickness, then you have to go for ball and flat disc coating testing facility. If you have if your conditions are, for example, you are developing one component for implant application like hip joint application or maybe knee joint application, where you have developed some coating. So if you can see that actual application of the implant material either for hip joint or knee joint, you will find that there is always a relative motion between the bone and then other joint. So that relative motion is not only always sliding only, but that is also a kind of micro fluctuating in nature. It is a little bit fluctuating in nature. So in that case you have to do the wear testing under fretting mode, and you have to also take the human body fluid as the media, because actually the wear is happening inside the body in presence of the human body fluid. So you can also use some lubricant. So these all situation exact wear environment you have to know, and accordingly you have to go on measuring the wear or using the wear testing facility for the measurement of the kinetics and the mechanism of wear. So this is about the kinetics of the wear. We talked about different wear testing, but if you are interested to know the micro mechanism, certainly as I mentioned you in wear class as well, that whenever you talk about the wear initiation mechanism may be one, but gradually as the wear proceeds, the mechanism wear propagation mechanism may change. So that is why it is very important that you measure the wear resistance or you measure the wear rate at regular interval, as well as you just observe the surface of the own material at regular interval. So what you have to do is that you just take out the material at regular interval and you find out the microstructure, you find out the phases which are present, and these all features you see, and from there, and also you correlate these features with the coefficient of friction, because whatever micro changes are there on the surface, that is visible on the in the coefficient of friction value, and from there you can finally establish the typical micro mechanism of wear when wear proceeds. So, though wear term is very important and very easy, and all testings are also quite easy, but actually whenever you just discuss about the mechanism, so you have to start from the very beginning of the initiation mechanism to the propagation mechanism, and finally establish a particular micromechanical or mechanochemical model for the wear of the material. So, in the next class we will discuss about the corrosion testing and different surface characterization techniques which may be applied for the post measurement of the wear or corrosion resistance property of any material. So, that is very important, so that you can understand that what are the different steps need to be followed for knowing the mechanism of different properties, particularly we discussed about wear now. So, thank you very much. These are the references which you can follow for a better understanding on the different mechanical testing process which we discussed here, particularly wear and fitting, micro hardness, these all values, these all are testings, and naturally tomorrow we will discuss about the corrosion testing and its mechanism analysis. Thank you very much.